My name is Dr. Rebecca Bilbrow. I am the CTO and co-founder of Rotational Labs. So if you're joining us again for another Rotational Labs webinar, welcome. If this is your first Rotational Labs webinar, I think you are in for a treat. We definitely do things a little bit differently. We do not kind of hype up any products. We don't do any sales pitches or anything like that. We're just literally kind of talking through our journey as practitioners of machine learning and data science and kind of sharing what we're learning, basically in real time as we learn it, sharing these best practices and trying to create kind of a community of practice, of people who are thinking about how to do better applied machine learning. So welcome to that community. We are a small tech company. We do services. Our customers tend to be customers who are really excited about AI and language models and LLMs, but they're afraid, frankly, of sending their first-party data out to third-party tools and AI chatbot type things, and they don't feel like they can handle kind of the privacy challenges, or they don't want to give up the IP. And so we come in and we build some kind of custom language model, and we deploy it on their own architecture, and they own it, and they can control kind of the privacy posture and the security posture. And that allows them to build kind of custom AI things on top of that without, kind of risking any kind of data leaks or security issues.
As you can see, there's a lot of layers in terms of your LLM knowledge journey. All of us are aware of the top level, which are these LLM-powered customer-facing applications such as ChatGPT, Gemini, and Copilot. But as you go deeper in this journey, there's a lot more control, that you have, and a lot more ability to leverage the capabilities that large language models provide you to deliver value to your organization. If you kind of just build a wrapper around ChatGPT, it can cost your organization not only money, but also reputation. And here, Air Canada was forced to pay one of its customers after its chatbot mistakenly told the customer that they could apply for bereavement rates and would be refunded when that was not in their policy. So the answer is to build your own domain-specific large language model. And by the way, it does not have to be a chatbot. Here's the thing, time and time again, you'll have a company that comes up with a product or service that's revolutionary, that earns them a lot of money, and there's a lot of buzz and there's a lot of hype. And the tendency tends to be for other organizations to just create a copy of that product or that solution in the hopes that they can also replicate that success. But the reality is that the way businesses get ahead is to differentiate themselves. What that really means here is that companies should be leveraging what they already know. Right? And other advantages of building domain-specific models are as follows. First of all, you can produce better results because these models are trained using your proprietary data. And by the way, it doesn't matter how fancy the model is. If you don't have good quality data that's relevant to your customers, you're not going to be able to build a good solution. Your proprietary data is really your IP, and leveraging that is going to give you a leg up in the market. By using domain-specific models, you can ensure that you're not giving away that data to some third party service. Right? You retain full access to that data, and you have full access to the model, and you control when you make updates to the model, and you have all access to all the versions of the model, ultimately having autonomy, and you're also able to guard against vendor lock-in and are able to cut costs. You can use open source models. And so Hugging Face, has the largest repository, a lot of pre-trained models, including ones from Google, Microsoft, and Meta for a wide variety of machine learning tasks. They have open sourced them to spur innovation, to build new products and services. And Hugging Face has done, continually adds a lot of resources to help you get started. Things like demos, use cases if you're kind of struggling to figure out what new use cases your organization can build upon to generate new revenue streams, and also just even data sets just to kind of play around with, if you don't quite, have a data quite ready yet, just to sort of get an idea of how to use these different models. because you're able to like download these models and kind of customize, you have the ability to customize these pre-trained models by feeding data from your own domain, which is a lot, smaller than the data that, ChatGPT was trained on. So again, it's more cost effective, and you can use your domain knowledge and leverage the expertise of your data scientists to tune these models. Hugging Face also offers other solutions such as inference endpoints. This way, say you build your custom model, you can deploy them, on dedicated servers that are available on Hugging Face. They also offer an enterprise hub. For example, you're a larger organization, you need like an enterprise wide solution for your organization. They offer this solution as well. If you have some use cases where you need some access to, custom, some state-of-the-art GPUs, they have, you can also, purchase these GPUs from Hugging Face. And if you need, they also have, machine learning experts that can kind of help you, help guide you and help you develop this capability within your organization to build your large language model application. Some of the machine learning tasks that are basic you have models for on Hugging Face are for computer vision. So for example, for text to image solutions or object detection, natural language processing is obviously the most popular one, with the development of ChatGPT. So things like question answering, translation, text classification. There's also audio, so you can do like audio classification, text to speech. Multimodal is also something that's been kind of gaining traction, where you can kind of use like different modes. Here, for example, visual question answering, image text to text. And there's also use cases for like tabular and reinforcement learning.
On a Hugging Face, we're looking at the Meta Llama 3, the 8 billion parameter version. There's also a 70 billion parameter version, which is a lot larger, but this one is like the smallest one they have available. And this one, you'll see, when you download, you'll see a bunch of files, and some files are just for README stuff. Like this matches kind of like what you'd see in a GitHub repository. So explaining like the terms of use and how the model is trained and what you can actually use the model for, and maybe some instructions about how to use the model. There's also some configuration that Hugging Face uses to load the model, and these are kind of describing the default parameters. You might recognize some of these if you've done a bit of LLM development, such as temperature, just kind of controlling how random versus how consistent the responses are, and the vocabulary size and things like that. The largest part of this is, of course, the weights in the neural network, which is where the actual model is kind of defined. There are 8 billion parameters here, and that the parameters with all the different types of tensors here take up about like I think that's like 16 or 17 gigabytes. So that's like the amount of storage you need on disk. So these models can get pretty large, and they're stored on Git LFS, because I assume they're just too big for GitHub, the normal GitHub. But lastly, we have a tokenizer config. So this is something that you will understand as you start working with Hugging Face models, is that there's a model part of it and a tokenizer part, and the tokenizer is very specific to how these language models are made, because the different vendors or different creators of large language models will probably have their own unique things for tokenization. They might have specific tokens for starting like a beginning of sequence, end of sequence, that you can see down there below. That kind of determines some of the factors when you're just tokenizing raw text for the model.